Hello students, today we are going to take a review of chapter 6, that is Newton's law of motion. This mainly it comes under the bigger chapter of laws of motion. Laws of motion has three important parts. So the first part is laws of motion has chapter 6, this is chapter 6, it is called Newton's law of motion, which is mainly deals with force. And the next chapter, chapter 7, will be dealing with friction, force and the friction of this one. And chapter 8, which deals with the circular motion. We already have seen all of them. Remember, all the three will come under this bracket of laws of motion. So, we are going to first of all take a review of only the chapter of force. That is Newton's law of motion. Mainly of Newton's law of motion we will be seeing. So, once we done this one, and we'll see how you have to learn this particular chapter. When you learn this chapter, how you will do it, we're just going to take a review on it. Okay. So first of all, I'll just give a major review. Newton's law of motion is the major part of it in force. So the first law, the law number 1, is need for force. We will be concentrating. Why do we need force? So especially the property which is there covering of this particular first law is inertia. Because of inertia, we need a force. So the body continues to be in a state of rest or in a state of uniform motion in a straight line unless and until a force is given. So inertia is a basic property of this one. Because of that inertia has to change, you need a force. Need for force is given. This doesn't have any kind of maybe a formula or maybe a kind of a conclusion. It is just a need of force. So sometimes they say, no, this is just a pseudo law. It doesn't have anything to finally conclude. It just says, no, you need a force. Alright. Second law, the law number 2, it says the value of force. How much is the force? That is very important. How much is the force? The rate of change of momentum is directly proportional to the amount of force given, and it takes place in the direction of the force. So that's what it is given there. So we take F is going to be equal to dP by dt. That is the main thing that we say. And also F is going to be equal to mass into acceleration. That's what the conclusion we make. Right? The value of force. How much is the magnitude of the force? And based on this one, we also deal with the important matter called impulse. Here we deal with inertia. Here we say impulse. So how impulse takes place because of Newton's second law. That's what it is already given there. So if you have a look on this, so the chapter itself, it begins with the inertia. So you can see inertia is given here, and there are three types of inertia: inertia of rest, inertia of motion, inertia of direction. All these things are there. You would have studied this one in the earlier classes itself, so it is fine. Then as you just go ahead, so inertia of motion and inertia of direction and all these things are there. So just to give a reading, that's enough. Quickly you have to pass through it. Don't spend much time in these first pages. Linear momentum, already momentum formula is known. So just you need to know the formula, and then which is heavier body, lighter body, which one has more momentum, all these things are there. Quick glance is needed, that's all. These are all stuff dealt with in 9th standard itself. And then there are 3 graphs are there, how it deals with the momentum and velocity, as well as mass and velocity, as well as mass and momentum, all this stuff. So you can just take a look on it. Now the next one is Newton's second law. We already have seen this. I just wrote this quickly. F is directly proportional to dP by dt, the rate of change of momentum. So differentiation, it comes here. It is not just mass into acceleration, it is differentiation it comes. So that's the way it is always looked at in class 11. So because in lower classes we always have learnt F is going to be equal to mass into acceleration, but here it is the rate of change of momentum. So which is given as a clear formula here. Now moving further down, because of this particular thing, the consequence of the Newton's second law of motion is given as the impulse here. So look at this one, impulse of a force. How is impulse is? So what happens in impulse? So these all things is given there. Impulse is nothing but it's change in momentum. So if you have a change in momentum, that is what impulse is, right? And also it is given here as how much is the value of it. So it is the measured external force. So you find it is the impulse is a measure of the degree of the external force, which is a change in momentum. Okay, so one important thing is it is a vector quantity. Impulse is a vector quantity. It is not a scalar quantity. I think sometime before I said it is a scalar quantity or something, it is a vector quantity. So there is illustrations about what is the change of impulse, all this stuff, right? The third thing is Newton's third law, effect of force. So need of force, first law. Second law is value of force, and law number 3 is effect of force. When you give a force, you will get an equal and opposite force reaction. Every action that gives a equal and opposite reaction. So effect of force means you give a force, you will get back equal amount of it. Whatever you give, you will get back. You apply a force, you will anyhow get a tug of it. So the law of conservation of momentum will come much more clear in this one, because momentum need to be conserved when you see the change in this one, the force which is taking place. So Newton's law of third law, it is action and reaction which comes. So it has the force as an equal and opposite reaction. So that's the way it closes here. It has quick examples are there. So these are all the basic part of it. Now, law of conservation of momentum, you need to be very, very carefully learning this one thoroughly. It's an important derivation also, and this concept runs throughout. It runs continuously for many ways. Even if you look at laws of work, energy and power, so in that one you find law of conservation of momentum is so much, it is dependent on this. So what is law of conservation of momentum? In the absence of external force, look at this one. In the absence of external force, this is the force equal to dp upon dt, that we already know it. When F is going to be equal to 0, no external force is acted here. So what happens here is, so dp upon dt is going to be equal to 0, because this formula says that way. Force is 0. That means when this differentiation becomes 0, if you have this variety of this, when it will become 0, now integrate and see both the sides. That means the momentum should be a constant value. When you have a constant value of momentum, you integrate this one, then dp upon dt will become 0, because constant value, when you differentiate, when you integrate, it becomes 0. So that's the way. So momentum is constant. That's what the final conclusion is. So that's what it is also shown here. Look at this one. dp upon dt is 0. If you look at the whole derivation, when dp upon dt is equal to 0, p is equal to constant. So in the absence of external force, the definition says, the absence of external force, the momentum, the total momentum, which is involved in that whole of the process, is always a constant. So in the absence of external force, the total momentum of the system remains a constant. That's what the definition says. So please learn this one thoroughly. I just told in a very quick terms what it is. And the illustration goes on, recoil of a gun, earth and the ball, and many other stuff which is there, right? Then you get into few things which is beyond this chapter. As we move forward, it says about Newton's law, second law is real law. So we try to conclude that if this is the important law, it governs this and it governs this also. From this one, you can get the third law, you can get the first law also. So this is a real law, that is force equal to dp by dt, or otherwise force equal to m into a. So we will try to see, this is the real law. We have already done this derivation. Please take a look on it. So there are two parts in it. So Newton's first law is derived from the second law, and also the third law also is derived from the second law. So this whole thing is there. You can take a look on it, right? And after this one, so once you do this one, so before itself I said about law of conservation of momentum. So this is the important derivation, and this is the next important derivation. Newton's second law is the third law. The next one is applications of Newton's law. So in the application of Newton's law, there are various applications it comes, right? So the first one is acceleration of the body, which is given a force. What happens when you give an to a body, when you give a force? How it accelerates. In that context, we have several things like various bodies we see. So a body which is given a force like this, just a force, and a body given a force in an angle like this, what happens? And a body given a force in an inclined plane like this, what happens when you give a force like this? So all the examples we see, and also, so these are the various ways. Now look at this one. These are force in a straight direction, force in an angle here, and force given to a body which is already on an inclined plane. These are the three things we see. The next application we see is, B part is connected motion. The force which is not just on a given body, but it is connected with anything else also. Suppose one mass is here, it is connected with another body with a rope. Always there is a connecting is there. Something is getting connected. So what happens there? There is a tension which prevails here, and then there is a force which is given here to the body, and body moves. The whole system moves. So how it happens? That is the connected motion. So the entire body goes in the acceleration. Similarly, connected motion, it takes place in the thing also when you are having two body system, and as well there is a rope which is inclined. How it happens? Then we also saw the connected motion in a pulley system. One body is hanging here, another body is hanging here. What happens? So this is going down and with an acceleration A, and this is going up with an acceleration A. This is also having m into g. So all these things. So we saw the connected motion here. Another connected motion is a body is here, and there is a pulley here, and this one moves down. So m into g and another m into g, capital M, small m. So what happens? This is also connected motion. So look at this. It has a train of things which is coming here. Connected motion means a rope which is there in a two body system, a rope which is there in an inclined body system, a rope which is connected with a pulley system, a rope is connected with the horizontal and a downward motion. All these things connected in the connected motion. So we already saw all of them in quick derivation format, how to do this. Now look at this one. So force given in straight direction, force given in an angular format, and force given to a body in an inclined plane, and going up an inclined plane, going down an inclined plane. All these things we have seen it, right? And we know this one, how it worked, right? So these all things. Now the question comes, sir, should we learn all of them? Should we learn all these derivations which is here? I would say take a look. You need not completely memorize these things. You have to know how this numerically it comes. This is all mainly of numerical parts. So this directly will not come in the theory portion. So I'm just giving you a clarity on that, right? Which will come in the theory portion is connected motion will come in the theory portion. Okay, motion of two body in contact when it is connected. Two bodies are connected here. All right, and as well as a rope is connecting here. Now look at this one. There's a rope connected here. So body is connected by string. This is important. It can come in the exam just like that. And then this also can come as a derivation. So when there's a pulley which is connected and there is a derivation which is there, we already saw the derivation. Please learn this derivation, which is acceleration and tension. And also we saw this one also. That is pulley which is here, and a horizontal table, something which is pulling down. This also could come. So remember, connected motion derivations are important for the theory part. The acceleration of the body, these derivations you need not learn completely. It's okay. Apparent weight of a body in a lift, optional, it's given here. Definitely it's optional. You need not learn these derivations, but you should know how it comes, because this is all numerically, it comes very clearly. So when it is just a body is there, the lift is there, which is that moving, then this is W is equal to m into g. When the lift is moving up, what happens? The weight increases. It becomes W is equal to mg plus ma is equal to g plus a. And when it is coming down and in lift, when the lift is just coming down, then it becomes W is going to be equal to mg minus ma. It becomes less, the weight becomes less. With that, this whole thing gets over. Concurrent forces you need not learn. Please don't learn this concurrent forces. It is just for an understanding you should need when a force, several forces act on a simple body, and also equilibrium of concurrent forces also it is there. You need not learn this derivations. It's okay. Don't spend time in learning these things. So strictly speaking, it is very simple theory portion. Law of conservation of momentum, Newton's second law is a real law, and then connected motion, few things are there, and that's it. And also already we saw about these basic things. These are all derivations which is needed. Impulse derivation and momentum derivation, and these all things are there. Theory portion wise it is very simple. Now what is also included in the theory portion, listen to me carefully now. Listen very carefully, don't miss this. Now the theory portion we will also consider it as the big concept question which comes. Very short answer type question which is given in page number 253. Page number 253, right? Very short type answer questions. Look at this one. So start from question number 1 and it goes on. Question number 10 and it continues till question number 17. Now look at this one. Question number 11, 12, 13 and then 14, 15, 16, 17. This much is there. Very short answer questions. You need to learn this one. This is considered as theory portion. There's no derivation, no calculation. So you cannot consider this as numericals. Similarly, based on apparent weight and law of conservation of momentum, 18, 19 and it goes on. Lots of numericals are there and it goes on to 22, 24 and 28, 29 till 29 it is there, and it goes on to the next page also as short answer type questions. So these are all short, very short answers. Now short answer type questions, two more questions. So please learn this. This is also based on force, and the next is based on conservation of momentum. Here that also it goes on till from 13 to 17 is law of conservation of momentum. So these questions are very important along with the derivations. Please learn this also, right? And the next part is numerical part of it. Numerically it is very strong. I didn't give any worksheet on this because this itself had quite a lot of numericals. We did all this exercise numericals right from 1 and it went on till 30 questions. All the 30 questions we have solved it. Please learn everything. Anything can come. Please learn all the 30. And also we did quite a lot of exercise questions down there, the example questions. Please learn them also. I think that is quite a good review that you have got how to do it. Theory portion you have to finish all the derivations, everything within 45 minutes to 1 hour. Don't make beyond that. And then the numericals will take at least 2 hours for you to revise. You need to really work on all the numericals. It will take time. Please do all of them. I think that itself will be giving a good idea and confirmation about how you can do. Alright, thank you.